Okay, so your test tomorrow does have some old topics on it, the first of which is inverses. So remember, some of you, the issue you guys had was actually on the next question about what it means to be one-to-one. We'll get to that in a second. But you will see this question again because it's an important one for us. How do you find the inverse of a function? Well, your first step is to switch the x and y. So remember, this is really a y. So when you switch the x and y, you end up with x equals 3y minus 7 over 2y plus 1. Now, clearly that is not in any sort of friendly notation. You need to solve for y, but the problem we're going to encounter is that there's multiple y's in the question. So you are going to cross multiply. And you're going to end up with 2xy, so I'm multiplying this right now, plus x equals, and then 1 times 3y minus 7 is boring. But we still have that same issue. There's too many y's in the problem, and they're not even isolated yet. So the next thing you're going to have to do is move all the terms together that have a y, and anything that doesn't have a y, move it to the opposite side. So I'm going to subtract this 3y over here, and I'm going to subtract the x over there. So you get 2xy minus 3y equals negative x minus 7. And keep your eye on the prize. Your goal is to solve for y. So now that your terms of y are collected, even though there's too many of them still, you can now factor out the y. And that leaves you with, what, 2x minus 3 equals negative x minus 7. And then you're almost home free. You're just going to divide both sides by 2x minus 3. But remember, you have to name the function accordingly. So if your original function was titled f of x, that means your inverse function would be titled f inverse of x. So it's negative x minus 7 over 2x minus 3. You guys do not have to worry about that being the best answer, whether it is or isn't, because I know all the equivalent answers. You don't have to worry about that. What does it mean to be one-to-one? How can you tell if a graph is one-to-one simply by looking at it? It needs to pass the horizontal and the vertical line test. So if this was your function, which is kind of a weird little sketch, it does pass the vertical line test, and it does pass the horizontal line test. So you're going to say, yes, this is one-to-one. And the reason is because it passes the horizontal and vertical line test. So remember, on the last test, your question was a multiple choice style. It said, which of the following is a one-to-one function? So you should have looked for the one that passed both tests. All right, now this one, same concept that you saw on a previous test, but this time your function is strictly linear. So they want you to find the inverse function, and they want you to graph both the original and the inverse function. So it's kind of up to you how you guys approach this. Seems like you guys are pretty confident on finding the inverse by switching the x and y. So that's what I'm going to do over here. I'm going to switch the x and y around. This one's linear, so it's nice and easy. You're going to add the 6 over. And then when you divide everything by a 2, since you're going to have to graph it, I might suggest you like simplify it and divide each term by 2 separately. And I already took the liberty of naming it for you. G inverse would be 1/2 x plus 3 when you simplify that. Now, as far as graphing goes, one of two ways. For most kids, they can just graph 2 lines, and then they look to make sure it has the correct reflection. So if the original line was 2x minus 6, oh goodness, I can't see that. 1, 2, 3, 4, 5, 6. I hope I'm down 6. I can't really see. And then we're going to travel up to right 1. Maybe. Up to right 1. Okay, I think I did all right. And then my Algebra 2 kids told me, actually my co-teacher informed me that I have what's called a shape pen. Look at that. Made a line for me. Isn't that nice? It's like it knew that I'm a terrible grapher, and it's like, it seems to me like you're trying to graph a line. Let me help you out with that. Where has this been all my life? Okay, so now we're going to graph the other line, the inverse that you guys just found, which is supposed to start at 3, and then slope of up 1 over right 2. And again, I'm going to use the shape pen since I can't draw. Now, there's another way for us to graph that inverse, because we know these are reflections across the line y equals x. But remember the xy ordered pairs are just flip-flopping. So like for instance, I noticed this guy went through the ordered pair 3, 0. So just to double check my work, did the inverse go through the ordered pair 0, 3? Yes, it did. So I feel like we've done something right. I like the visual of the, once they're both graphed together, that I could see that they're reflections across the line y equals x. You don't have to draw in that line, but if any point in the future, if I said like justify that these are inverses of each other, that is one of the justifications, that they're reflections across the line y equals x. All right. Oh, that would have been better to use because those are bigger. Okay. Next one, number 4. So this is a repeat section, guys. We are going to graph. We're going to analyze the function. So the first thing you'd have to do is get this typed into y1. So remember the cube root feature can be found in your math menu. And then make sure the quantity x minus 1 squared is underneath the radical. You're going to get something that looks like that. So because of the nature of the function, we can assume that there's arrows on both ends of these little blue lines here. And if you did a little calculator work, you'd probably recognize that this little cusp is happening at x equals 1. So this is where textbooks get into a great debate as far as like what does that mean for that ordered pair. When we're graphing it, I don't need anything real beautiful, guys. I should have paid attention to the Y-intercept, but I didn't. Oh man, that was extra ugly. Let's try that again. In a minute, they're going to ask me about the Y-intercept. I should have written that down. Oh well. Talk to me about domain, guys. Remember domain being from left to right. How far left and how far right is this function going? Kind of goes forever, right? So negative infinity to infinity. What about range? Starts at negative infinity, and it stops at y equals 0. Now, there is an ordered pair at 1, 0. This ordered pair here is literally the ordered pair 1, 0. Something weird happens there, but yes, it is the ordered pair 1, 0. So this is where I'm going to take a few different answers. For x-intercept, some people will claim that they're going to call 1 an x-intercept. Technically, most textbooks say that's not an x-intercept because it doesn't cross through the x-axis and become a positive value of the function. So, like on my answer key, I'm going to have the word none. But if you said there's an x-intercept at 1, 0, I'm not going to count you wrong. It's a great debate among mathematicians. 1 is a 0 of a function, 1 is a solution to that function, but technically 1 is not an x-intercept according to most textbooks. So that's a little bit of a vocab issue. It gets weird in calculus, so we'll talk about that later. Y-intercept. There's a couple ways you could find that. You can find it algebraically, but remember, y'all have it on your calculator, so I would just hit trace, and then it's probably going to pop up. But type x equals 0, and then boom, it's at negative 2. Which I totally didn't make. It was supposed to cross right here. So, sorry. And then, end behavior. End behavior, remember, is the f of x stuff. So f of x approaches blank as x goes to the left, and f of x approaches blank as x goes to the right. Now, regardless of which end you're looking at for this particular function, it's going downwards on both ends. So I'm going to say negative infinity on both of them. And then they're going to ask you if it's continuous. Remember, if it's discontinuous for us, you're looking for holes or jumps or asymptotes that don't connect. So yes, this one is continuous. All right. This stuff's showing up again. Remember we warmed up with these the other day? So we're going to be getting rid of, quote unquote, the radical. This is a square root, so you're going to want to square both sides. And as long as the radical is isolated as much as possible, it's a good time to square. So this would be a great time in your problem to go ahead and square both sides. The left side, easy peasy, you just radical and the squared cancel each other out. But be careful on the right side, it's x plus 1 quantity squared, so remember that's a foiling question, x plus 1 times another x plus 1. So you're going to get x squared plus 2x plus 1. And then your approach depends on what you're looking at. I'm looking at a quadratic, so usually when the quadratics pop up on these questions, that means we're going to be able to factor. So let's get it in standard form. I'm going to add the 3x over. I'm also going to subtract the 25. So we get x squared plus 5x minus 24. Yeah, that should factor nicely. How about x plus 8 and x minus 3? For your factors, which means your solutions are x equals negative 8 and x equals positive 3. And after all that work, we feel like we deserve to just box our answer in and move on. However, we're not going to because you need to check. So you guys did a nice job of checking last time. Unfortunately, some of you put your check answer as your answer. So just be careful. You're checking to see if these answers work out. Once I find out that they work out, then I'll go back to my solutions and box them in. So let's see if negative 8 works out. So if you plug in negative 8 into the original question for x, you get 25 minus 3 times negative 8. Does it equal negative 8 plus 1? I can already tell this is going to be a no solution, or this solution is not going to work because you're not going to be able to have a square root equaling a negative 7. But for funsies, let's figure it out anyways. 24 plus 25 is 49, so this is the square root of 49. Does it equal negative 7? No. Square root of 49 equals positive 7, so no, that doesn't work. So that answer is extraneous. And then when you go to plug in x equals 3, you get 25 minus 3 times 3. Does it equal 3 minus, plus 1, excuse me. So it's 25 minus 9, that's 16. Does the square root of 16 equal 4? Yes, it does. So this is your answer. Don't tell me 4 is your answer. That's the solution for the check. And you do have to go through all that algebra and show me that x equals negative 8 is extraneous. I'm expecting an algebraic approach to this question. Now, 6 I'm a little concerned about because, yes, we are ready to square both sides. The problem is you're going to have like a radical within your squaring, and we're going to have to square again. So the left side is the problem this time. When you have the square root of x plus 5 times another square root of x plus 5, if you feel like this is where you mess up the question, you might want to write them out twice like this. Square root of x times square root of x is going to be x, because it's like you're squaring the square root. And then you have plus 5 square roots of x plus another 5 square roots of x, so you have plus 10 square roots of x. Whoops, x I said. And then 5 times 5 is 25. Squaring the radical, easy. That's just x plus 29. So when I kind of step back and look at that equation, I notice we still have a radical. So now you got to start all over again. You want to square both sides of the equation, but not until it's a good moment. This is not a good moment to square. Let's start moving things. This one works out kind of nice, though. You're going to subtract the x and subtract the 25. And you end up with 10 square roots of x equals 4. Now, you can divide by 10 right now, and you'll have a fraction and or decimal. You could square both sides right now, and then you'll get a fraction next. I don't care. I don't like fractions, I'll be honest, unless like that's my only option. So I'm just going to square now, but you could have divided first. It doesn't matter. You're going to end up with, this is going to become a 100, and then squaring the square root will just come out with x equals 16. So right here I'm going to have a fraction. Happens to be the same fraction I would have gotten had I divided by 10 to begin with, but that does reduce, guys. What's 16 over 100 when you reduce it? 4 over 25. So, oops, I shouldn't have boxed it in yet, because what did I forget to do? I forgot to check it. So you should go back and check, I suppose. So it does the square root of 4 over 25 plus 5 out of it equal the square root of 4 over 25 plus 29, all under the radical. So since you're checking, you could literally just type each side of the equation into your home screen and see if the decimals match. They do, because I know this one works. All right, moving on. This is new stuff. All right. I'm really hoping we can get this one on the first try, guys, so we don't have to test this one again next test. They want you to know a little bit of vocab here. What is the degree of your function? Well, this function is not in standard form. So in order to find degree, you're going to have to think about what's going on here. You have, I'm actually going to take the lead terms for everything. I see a 2x squared, which is going to be multiplied by an x to the third, which is going to be multiplied by an x. So your lead term is actually a 2x to the, add them up, what is that, x to the 6th? So I don't really care about the rest of the polynomial, but the lead term would have been 2x to the 6th power. So the degree is 6, and the lead coefficient is a positive 2. So with that in mind, a degree of 6 is a cousin of the quadratic. So the ends either go up, up, or down, down. Which one is this? Up, up. Yeah. So the ends go up, up. I'm just going to make a little note to myself. They want zeros. Should you be grabbing your calculator on this question? Not at all. And this is where some kids get into trouble because they're very calculator dependent. And they're like, oh, I don't have time to finish this test. Well, that's because you were trying to confirm things on your calculator when you weren't supposed to. This is a moment where you're not supposed to touch your calculator. Your zeros are found by just setting your factors equal to 0. So if you set this factor equal to 0, you get 0. But how many times does that solution show up, guys? Twice. Very good. So you're going to write 0 multiplicity 2. It shows up twice because of the power on the x. And then this solution, which is 2, how many times does that show up? 3 times. So multiplicity 3. And then this solution is negative 1. And you can say multiplicity 1, but I just assume that if it's once, you just don't write anything. Okay? So we found 1, 2, 3, 4, 5, 6 solutions. And now end behavior. We already kind of mapped it out. The ends are both going upwards. So on the left side and the right side, your function is going up to infinity. Again, didn't touch the calculator at all. Not needed. So when you're looking to save yourself time and energy, this is one of those questions where you shouldn't have to touch the calculator. Now here, you also do not have to touch the calculator. So put the calculator away for a moment. The number of possible real zeros, and I should say rational zeros. So possible rational zeros is indicated by the degree. So the degree here is 4, which means there's at most 4 rational zeros. Do you remember how we find the possible number of turning points then? 1 less than that, so 3. So whatever the degree is, minus 1. Factored form. Notice nowhere in the instructions does it say, grab your calculator and do something. Factored form means your brain can do this, guys. This is a trinomial. So we're going to factor that trinomial. X to the 4th for your lead term would have to be factors of x squareds for this problem to work out because of the middle term. I need my back numbers to multiply to 44 and add up to negative 15. So how about like a minus 11 and a minus 4? But are we completely factored yet? For sure, no here. This is a problem. And for bonus points in my heart, if you can factor this, like in my heart, you'll get bonus points, not necessarily in the grade book. So x squared minus 4, how do you factor that? X plus 2 times x minus 2. And then in the same pattern, you can technically factor x squared minus 11 for bonus points. What you got? X plus the square root of 11 and x minus the square root of 11. So this answer is like my absolute favorite. But if you wrote down x squared minus 11 times x plus 2 times x minus 2, I'm still going to give you credit for that. But like I said, this one's my absolute favorite, because that means you truly do understand what the difference of two squares means. And now when it says find all exact zeros, if you're in that ultra fancy factored form, you can see all 4 zeros really clearly. You can see that there's positive square root of 11, there's negative square root of 11, there's positive 2, and there's negative 2. If you went shortcut style and said plus and minus square root of 11 and plus and minus 2, I'm okay with that. I prefer you to list them out separately, though, on this question. So, favorite answer. Also my favorite answer. Because I know you guys live to impress me on your tests, right? Yeah. Just want a sticker. All right. Again, you might use your calculator for computation here, guys, but you shouldn't be graphing this function at any point here. So you should be able to tell me from the little visual I gave you whether this is an even or odd degree. Now, nothing to do with even and odd symmetry, guys. Even and odd degree. Is this even or odd? It's even. How can you tell me it's even? Or why can you tell me it's even? Because it's a cousin of the quadratic. Both the ends are going in the same direction, so that's an even degree. Multiplicities. Do you guys see any zeros that have multiplicity? Now, they did list them out for you pretty clearly up here, that there's a 0 at -4, 0, and 5. So this is -4, this is 0, and this is 5. Do any of those zeros indicate that there's sort of multiplicity going on? Yes, -4 seems to have some multiplicity of 2. Let's just assume anytime it bounces, it's multiplicity of 2 for our tests. Technically, one could argue it has could have multiplicity of 4. You guys wouldn't be able to tell that without further inspection. So we'll just assume multiplicity 2 when you see it bounce. So now, this is the fun part. They want you to find k, which is the stretch. So the formula for this even degree polynomial, I'm going to write it here. Y equals, there's some mystery coefficient. I have no idea what it is, but I think I can tell that it's negative. Can you guys tell that it's negative? It's opening upside down, so whatever this k is, it must be something negative. So let's write our factors in factor form with multiplicities. So like this first one of -4, you guys told me that the factor of x plus 4, so the solution at -4, has multiplicity of 2. So make sure you sneak in a 2 right here. And then the factor for x equals 0, you can write x minus 0, or you can just write x, I don't care. And then for a solution at x equals 5, that would be the factor of x minus 5. So that's you setting it up. But there's one other clue out here. Do you see it? When x equals 1, y equals 300. Fantastic. What do we do with that? Plug it in for x and y, yeah. So here's an x you can use, and here's a y you can use. There we go. 300 equals, I don't know k. But then x plus 4 would be like a 1 plus 4. Guys, biggest mistake here in this question, the child loses the fact that this quantity is squared. That's 1 plus 4 quantity squared. Okay. And then this factor would be 1 minus 0. And then this factor will be 1 minus 5. Okay. So all of this is some number. All right, let's see how my mental math is today. That's 5 squared, 25 times 1 times -4. Is that -100? Okay, cool. So this says 300 equals k times -100. So if you divide both sides by -100, y'all just found that k equals -3. So we are technically done. You just got to put the things in place of where they belong. So you just found out that k was -3, so throw it right there, -3. And then go back to your factors from this setup step. So x plus 4, don't forget that quantity is squared. You can say times x minus 0, there's nothing wrong with that, times x minus 5. The only thing you might want to consider is that instead of x minus 0, maybe you just wrote it as x. So for a lot of kids, I'll see this as their answer. -3 times x plus 4 squared times x minus 5. So literally, anything that's mathematically equivalent, I will accept. As long as it's mathematically equivalent and appropriate. So that one might take you a little bit to get everything kind of set up. Those are, I'll be honest guys, those are the questions where like sometimes y'all in particular, because you're stressed out, like you're trying to save time by not writing pieces of it down. And in doing that, you create a very large scale mistake. So take the extra like 4.8 seconds to write like x equals 1 everywhere. Don't just do that stuff in your head. All right, on your calculator, you're going to need to get this data entered. We're going to do some regression. So get the x's. Mine's entered into list 1 and list 2. So if you want to follow along with me, do that as well. All right, so once your data is entered into list 1 and list 2, you have to look at the scatter plot to make sure that the type of regression you're going to choose is appropriate. So I'm going to go to my stat plot. I'm going to choose plot 1. I'm going to turn it on, and I'm going to make sure that it's plotting my data where I put my data, which is list 1 and list 2. It is. Now the other thing you have to watch out for when you are plotting something is that you delete old problem, so delete that other question that we graphed earlier, and then you're going to want to zoom 9 this. Stat zoom will tell you whether your picture is pretty or not. You'll be able to look and see, oh look, does that look like a quadratic to you? Looks like a piece of a quadratic to me. So let's do quadratic regression on our calculator. So stat, over to calculate, and then use quadratic regression. My data is not there. Let's see, list 1, list 2. And then please do store it in Y1. So when it's frequency list should be empty, and then storing your regression equation, go to varies, over to Y varies, choose function, Y1. They're probably going to want the equation, so let's jot down the equation. It does not say where to round. Let's go 3 decimal points, please. So 0.042x squared minus 0.004x plus 0.043. It doesn't ask you for any sort of correlation. But it does have one follow-up question. It says, predict the braking distance of the car when it's going 80 miles per hour. So speed was your x variable. Your job is to, quote, plug in x equals 80. So since I have the graph, I'm going to go look at the graph. It's got the regression equation at the same time. And when I hit trace, it's going to default to the first thing you plotted, which is our scatter plot. So to get to the line, you need to hit the up arrow, and it'll hop to the next function, which is the regression equation. And you just need to type in 80. You could have, or not. You know why it's telling me invalid? It says right here, the variable's not valid because my window is not big enough. So I'm going to go to window. My max is stopping at 76. That's why it's having trouble. I'm going to go to 90. I couldn't extrapolate the data. The window was too short. All right, here we go. Trace. Get up to the right function. And then type in an 80. So 267.6-ish feet. All right. Another section, 2.3. Let's see. Okay, this one, they want you to use synthetic division to divide, show your work, and then write the quotient, and then you're going to answer whether or not it was a factor. Okay, that's a lot of stuff. So we're going to perform synthetic division, and you must perform synthetic in this case because you're showing me that technique. So in the box, you put the solution to your divisor, so -3. And then you set up your coefficients. Guys, please be careful about any missing coefficients. 4th degree should have 5 coefficients. Uh-oh, we're missing somebody. Who are we missing? The quadratic, yeah, so it's 3, 2, and then no quadratic term, -1 and a 65. So you're going to perform the synthetic division, which is just a series of multiplies and adds. Yeah, let's see if I can do this without messing up today. I probably already messed up. Did I already mess up? All right, -63. I super messed up. What did I do? Or maybe not. Is this just coming out funky? Okay. I'm so used to getting remainders of 0 from our last lesson. I guess we don't have one this time. All right, nail bully. What's that number going to be? 257? No, that's not right. Was it? 192. Thank you. The answer is 257. Gotcha. So this guy down here, the remainder is 257. So the quotient polynomial is, these are the coefficients to it. So you have 3x to the, remember what you did here, quartic divided by linear. So 3x to the third minus 7x squared plus 21x minus 64. Uh-oh, I'm running out of room. How do you write this remainder? Plus 257, and he's remainder because he's still being divided by the x plus 3. Somehow you got to sneak in that whole quotient. And then the next question says, is it a factor? Oh, this is a typo, guys. Sorry about this. Was x plus 3 a factor? Well, was it? No. And how can you tell me the answer is no? Because the remainder came out to not 0. So if it's a factor, it should have had a remainder of 0. That's why I got so confused. So you can just, for now, just write down remainder does not equal 0. Works for me. All right, now you get up. You must perform long division. This time, 4x to the third plus 12x squared plus 3x minus 5. It's being divided by... Now your divisor's a quadratic, so just watch out. It's got a lot of terms. And you start long division by dividing. So lead term divided by lead term. I like to write that off to the side. So 4x to the third divided by 2x squared would be a 2x. And then you multiply that into the divisor. So you get a 4x to the third plus 2x squared minus 2x. Now you're going to subtract. Watch out on this step that like everything's lined up. Once in a while we get divisors that are missing terms, and you got to be careful that like your x squareds line up with your other x squared. So just watch out for that. Here you have a 10x squared. The lead term does cancel. 10x squared and then plus 5x. Bring down that last term, and then if we go through this one more time, we're going to be done. So your new lead term, which is 10x squared, is still being divided by 2x squared, and it gives us a positive 5. So this time the positive 5 gets thrown into that divisor. So let's see here, 10x squared plus 5x minus 5. Oh, this is nice. You're going to end up with what for a remainder? Nothing. All right, so your quotient is just that 2x plus 5. So what can you tell me about this divisor? If the remainder came out to 0, it must be a factor of this original problem. Yep, very good. All right, this question does not require a calculator, so keep the calculator put away. Write a polynomial of least degree with real coefficients in factored form, okay? So you don't have to do that crazy thing where you FOIL it all back out together. So this is really asking, do you understand what zeros mean, and do you understand the conjugate theorem? So if you have a 0 at 0, that means you can just say x, or for a lot of you, you like to write down x minus 0 to kind of stay consistent. That's fine. And then you also have zeros at positive and negative 3. So we'll write down x plus 3 and x minus 3. This is the one I'm worried about. So if you have a 0 at negative 2i, that would be x plus 2i. We done? No, because why? There's also a secret 0 at x equals a positive 2i, the conjugate theorem. So over here, we'd have to kind of write a little note to ourselves and positive 2i. And then are we done now? Because a lot of kids think we are, but the directions said you can only have your answer with real coefficients. So the problem we're going to encounter is this part right here. The good news is, since they're conjugates, you can FOIL them back together pretty quickly, and then we can leave it in factored form after that. So FOILing this back together, you guys get x squared, the minus 2i and plus 2i x's are going to knock out, and then you have a minus 4i squared. Ladies and gentlemen, what is I squared? It's negative 1, so negative 4 times negative 1 is really a positive 4. You can change this back to an x if you don't want to write x minus 0. You're going to leave this as x plus 3 times x minus 3. So the only thing you had to be really careful about was you did have to multiply those complex conjugates together. All right. All the possible rational roots. here we go. I don't know what this line is. It's just nothing. All the factors of 6, what are they? 1, 2, 3, and 6. All the possible factors of 3, well, that's not too bad. That's just 1 and 3. And then we have to remember it's both positive and negatives of all of these. So here we go. I don't mind if you guys just throw a big plus or minus in front of your list. If you're listening from Mrs. Hoffbauer's class, I think she wants you to put a plus or minus in front of each term, okay? So if I divide all these by a 1, that's easy. That's 1, 2, 3, and 6. And then now I'm going to divide them all by 3. So 1/3, 2/3. Should I bother writing down 3/3? No, I already wrote that down as a 1. And then 6/3, I already wrote that down as a 2. So here's your list. So 1, 2, 3, 4, 5, 6, 12 different 12 different rational roots that were possible. Ooh, I misspoke earlier. I said some gibberish about rational roots earlier. It's supposed to be real zeros. I don't know what I was talking about. Like 12 questions ago. All right, they want you to now graph. So this is a big indicator that you're going to be using your calculator. And then you're going to use a possibility of successive synthetic divisions along with factoring to figure out what's going on here. I'm going to give you a little heads up though, guys, because we're stuck on time. Try -2. So, spoiler alert, on your calculator, x equals -2 is a definite root of this polynomial. So that's good news for us, because if we start with a cubic, which way back here was the problem, if you start with a cubic and you do synthetic division one time, then you can continue on and factor. So I'm going to use -2. I have cubic and not missing any terms this time. Now, unless your teacher lied to you, you should be getting a 0 remainder on this step. So let's see. Here we go. -10. That's a 20. And that's a 3. Oh, good. And that's a -6. We did get a remainder of 0. Go us. So this right here, from your calculator, if you saw other roots, you could continue to do successive synthetic division, but I think this one comes out kind of nice. So let's go ahead and factor this to solve it. And if it doesn't factor, your other option is to go and do quadratic formula. So let's see. I'm going to cheat a little bit. 3x minus 1 and x minus 3 I think works. Yep, that'd be -10 in the middle. So this guy is going to give you a solution of 1/3. This guy is going to give you a solution of 3. Are those all my zeros? No, where's the other one? Yeah, the thing we used from the calculator is also a 0, so -2. So 1, 2, 3 different solutions. And then where it says explain how you confirmed each root, it's going to be some gibberish about, like, you know, I used my calculator to find a starting root of -2, and then I used synthetic division to knock it down to a quadratic, and then I factored it to solve for the remaining factors. You could claim that you that you verified them on your calculator by hitting like trace 1/3, trace 3. There's a lot of things you could write here, guys, but you're going to be writing me a little explanation of your process. And then be careful here, factored form. The problem we're going to run into is a kid who sees all 3 zeros, and they write down x minus 1/3, x minus 3, and x plus 2. Does anyone want to throw out what's wrong with this answer? Because that's a kid who looks at the calculator and just looks at these 3 roots and then throws them into factors. This is not correct. What's the lead coefficient from your original problem? A 3. So if you don't have a 3 on your final answer's coefficient, you need to make sure you realize you lost your 3 at some point in your math. Now, this is why I like you guys to break down to a quadratic and then don't go any further than that. If you just looked at your quadratic factors, you would have had it. 3x minus 1 times x minus 3, and then times that x plus 2 from original. So either one of these answers is good. You just need to make sure that before you walk away from that question, that you have a coefficient that matches your original coefficient. So really watch out for that. Hey, was that the end? We made it. Good job.